I am Dr.V.Meenakshi, working as Associate Professor in the Department of Electrical and Electronics Engineering, Sathyabama Institute of Science and Technology, Chennai. Today we are going to discuss about the mesh analysis. So first we should know what is meant by mesh analysis. Then we should know what is the limitation and advantages of mesh analysis, and we are going to see the example also in this session. So first we can go for what is meant by mesh analysis. Mesh analysis is defined as the method in which the current flowing through a planar circuit is calculated. That means you can calculate the current in any planar circuit by using the mesh analysis method. You should know what is meant by a planar circuit. So the planar circuit is defined as a circuit that are drawn on a plane surface in which there are no wires crossing each other. So in the surface you should not have any wires. Then that surface we will be calling as a planar circuit. Therefore, the mesh analysis can also be known as loop analysis or mesh current method. Now we are going to see the advantages of mesh analysis, then limitation and disadvantages. Advantages of mesh analysis: it generally allows for the solution of a large network with fewer unknown values and fewer simultaneously equations. This is an advantage of using our mesh analysis. Limitations and disadvantages of mesh analysis are: we can use this method only when the circuit is planar, otherwise the method is not useful. Only for planar surface we can use a mesh analysis, for other surfaces we can't use our mesh analysis. If the network is larger than the number of meshes will be larger, hence the total number of equations will be more, so it becomes inconvenient to use in that case. Limitations means it can't use for more networks. That is the limitation of your mesh analysis. Now we can learn how to identify the meshes. So let us take this circuit. In this circuit you can see two loops are there. So loops means it's nothing but a closed path we used to call as a loop. So each and every loop we are going to assuming as a mesh. In this circuit, if you are saying means we are having two loops. So these two loops are considered as mesh. So first loop is nothing but it consists of voltage source V1, 1 kilo ohm, 1 kilo ohm. So this is one loop. So this loop we are going to consider as mesh 1. Similarly, the second circuit, we are having a second closed path, 1 kilo ohm, 1 kilo ohm and this V2. This forms you the second loop. The closed path forms you the loop. So we are going to assume the loop. We can call this as a loop or mesh 2. So in this circuit we are having two meshes. So mesh, how we can identify the mesh means based on the loops we are going to identify the meshes. In this circuit we are having three loops we are having. So this is a first loop. So we are going to consider this as a mesh 1 and this is your second loop. We are going to consider this as a mesh 2 and this is your third loop. We are going to consider this as a mesh 3. So in this circuit we are having two meshes and in this we are having three mesh circuits we are having. Like this we are going to identify the meshes. Next we can see the how to form the matrix in the mesh analysis by using the Ohm's law, V equal to I into R. By using our Ohm's law we can find our mesh analysis. If the circuit contains two loops, the matrix will be 2 cross 2 matrix. So this is our 2 cross 2 matrix we are having. R matrix into I matrix equal to V matrix. So R matrix means R11, R12, R21, R22. So 2 cross 2 matrix we are going to form if we are having two loops. Suppose if we are having 3 loops in the circuit means we will be going for 3 cross 3 matrix we will be going. So 3 cross 3 matrix R matrix into I matrix, that will be equal to a V matrix. So R matrix how we will be forming means R11, R12, R13, R21, R22, R23, R31, R32, R33. Like that we will be forming. This is our 3 cross 3 matrix. So we can see the explanation for each and every term in the resistance matrix. So let us go for R11 means sum of resistance in the loop 1, R22 means sum of the resistance in the loop 2, R33 means sum of the resistance in the loop 3, R13 and R31 will be same. That is nothing but sum of the resistance in loop 1 and 3. And R12 and R21 will be same. That is nothing but sum of the resistance in the loop 2 and 1. R32 will be equal to R23. That means sum of the resistance in loop 2 and 3. Next we can see the explanations for the voltage. V1, V2, V3 we are having in this matrix. Explanation for V1 is nothing but sum of voltages in the loop 1. V2 means sum of the voltages in the loop 2. V3 means sum of the voltages in the loop 3. Next we can see the explanation for the I1, I2 and I3. I1 is unknown loop current in loop 1. I2 is unknown loop current in loop 2. I3 is your unknown loop current in the loop 3. That means by means of mesh analysis, we can find the loop currents. So for that reason only we are going for our mesh analysis. We can see the rules of the mesh analysis. So rule 1, first rule, all the diagonal elements are positives. Suppose if I am taking a 3 cross 3 matrix means my diagonal elements will be R11, R22, R33. All the diagonal elements should be positive. Then second rule is all the non-diagonal elements are negative if all the loop currents are in the same direction. So the meaning for the rule 2 is nothing but if I am considering this circuit, in this circuit I am having 2 loops. This is my first loop, this is my second loop. In each and every loop you have to assume a current. So in the first loop I am going to assume the current as I1. In the second loop I am going to assume the current as I2. So if you are assuming I1 and I2, you have to assume the directions of current also in the circuit. So I1, I am going to assume my current is going to flow in the clockwise direction in the first loop. So you can see this arrow mark red color. So this indicates that the current is flowing in the clockwise direction in this loop 1. Similarly, the current for the second loop, you are going to assume the current as I2, that is also going to flow in the clockwise direction. So if you are seeing this circuit, what you can observe means both the current I1 and I2, both the things are flowing in the clockwise directions. So if both the currents are flowing in the clockwise directions, for non-diagonal elements you can make it as negative. If both the currents are flowing in the clockwise direction, you can assume the non-diagonal elements as negative. So we can see the rule 3. Rule 3 is the non-diagonal elements are positive. So when the non-diagonal elements will be positive means, see the circuit. In the first circuit, we are having the current we have assumed as I1. If you are seeing the direction of the current means, it is flowing in the clockwise direction. If you are considering the second loop, you can see, assume the current for the second loop as I2. This I2 current is flowing in the anti-clockwise direction. That means I1 is flowing in the clockwise direction, I2 is flowing in the anti-clockwise direction. That means the two directions of current are differing. So whenever the two directions of currents are differing, you have to keep your non-diagonal elements as positive according to this circuit. So let us see an example. So let us take this circuit. In this circuit, you are going to find the mesh current, branch currents and branch voltages. So this circuit consists of 2 loops. So this is your first loop. Your first loop consists of 15 volt source, 5 ohms, 10 ohms. This is your first loop. So assume a current for the first loop. Let us assume the current as I1 for my first loop. So let me assume in the clockwise direction. If you want means you can also assume in the anti-clockwise direction also. Myself I am going to assume in the clockwise direction. That is, in my first loop my current is going to flow in the clockwise direction. I1 current is going to flow in the clockwise direction in my first loop. So second loop in the circuit is, second loop consists of 10 voltage source, 10 ohms, 6 ohms and 4 ohms. So this is my second loop. So for this second loop you assume a current. Let us assume the current as I2 in my second loop. You can assume what are the currents you want. You can name it as you wish. So let me assume as I2. Let me assume the I2 current is also flowing in the clockwise direction. So if I am seeing the circuit, both my I1 current is flowing in the clockwise direction. My I2 current is also flowing in the clockwise direction. Since I am having a 2 loop, I have to form 2 cross 2 R matrix I have to form. I have to use my Ohm's law. Ohm's law is nothing but V will be equal to I into R matrix. V matrix will be equal to I matrix into R matrix. That is our Ohm's law. Let us find the R matrix for this 2 loops. So first you find 2 cross 2 matrix means you will be having R11, R12, R21, R22. So first to form your diagonal elements. R11 means add all the resistance in the first loop. So this is my first loop. Add all the resistance in the first loop. That will give you the value for this place R11. So what are the resistors are there in the first loop? We are having 5 ohms and 10 ohms we are having. So 5 plus 10 we will be having 15 ohms. So my R11 value will be 15 here. Then coming to the second loop, add all the resistance in the second loop. See the second, in the second loop we are having 10 ohm resistor, 6 ohm resistor and 4 ohm resistor. Add all the resistors value. So 10 plus 6 plus 4 you will be getting 20. So in my R22 place, in the diagonal elements I will be having, in place of R22 I will be having 20. So I have found out my diagonal elements. R11 is 15, R22 is 20. Now let us go for finding the remaining elements, that is non-diagonal elements. That means I have to find R12 and R21. So we know that in matrix R12 value will be equal to R21 value. So both the values will be same in case of a matrix. So let us find, if I find R12, that will be equal to R21. So R12. So what's the meaning for R12? R12 means nothing but the resistance common for a first loop and second loop. So see the circuit. In this circuit, which resistance is common for your first loop and second loop? For first loop and second loop, the common resistor is 10. So you have to write the value of 10 in place of R12 and R21. Both the value will be same. You have to write it. How to put the sign as a negative means, if you are seeing the first loop, see the current I1, trace the current I1, how it is flowing. I have assumed my current I1 is flowing in the clockwise direction. So my I1 current will be flowing from 15 volt, then it will crosses 5 ohms, then it will come here at the top point of my 10 ohms. That means my I1 current is entering at the top point of my 10 ohms. My I1 current is entering at the top point of my 10 ohms. Coming to the I2 current is flowing from 10 volt, then it enters the bottom point of my 10 ohms, then it crosses the 10 ohms, 6 ohms, 4 ohms and the circuit is ending. That means I1 current is entering at top point, I2 current is entering at bottom point. If you are seeing, both the currents are entering in the different places. I1 current is entering at top point of the 10 ohms, I2 current is entering the bottom point of the 10 ohms. So whenever two currents are entering the common resistors in different places, you have to make the sign as negative sign. So you can see the notations I have given. I1 current is entering the 10 ohms is indicated by red color. I2 current is entering the 10 ohms, that is indicated by blue color. Both the places are different places. That means both the currents are entering the 10 ohms at different places. So I have to make it as a negative sign. So put negative sign for 10, R12 and R21. So this is our, like this we have to find our R matrix. Then I1, I2 only we are going to find in our mesh analysis. Then we are going to find the voltage V1 and V2. So check what are the sources are there in the first loop. So first loop, if I am seeing, means this is my first loop. In the first loop I am having 15 volt and also 10 volt. So how to identify the polarity means, you see that I1 current, how the I1 current is flowing across here 15 volt. So I1 current leaves the positive of the 15 volt. So you have to put plus 15. I2 current means it also leaves the positive of the 10 volt. So you will be getting 10 volt, you will be getting as your voltage source V2. You will be getting as 10. Then from this you consider this matrix as your del matrix. So solve the 2 cross 2 matrix. If you are solving, that is 15 into 20 minus of minus 10 into minus 10 will give you the 200. So that is your del. Del value will be 200. So now we can find our del 1. How to find the del 1 means, in the del matrix, instead of the first column, we are going to replace with our voltage source. So first column is 5 and minus 10. That should be replaced with the voltage source. Voltage source we are having 5 and 10. Replace with 5 and 10. So instead of 15 and minus 10, first column it has been replaced by 5 and 10. Remaining second column will be as such, minus 10 and 20. Solve this 2 cross 2 matrix. So 5 into 20 minus of minus 10 into 10, you will be getting the del 1 as 200. Similarly, find del 2. So, how to find the del 2 means replace your second column with the voltage source. So, I am replacing my second column with the voltage source. What is my second column in the del matrix? Minus 10 and 20. That should be replaced by the voltage source 5 and 10. So, my del 2 value will also be 200. So, I have found out all my del values. Del value is 200, del 1 is 200 and del 2 is also 200. Now, let us find the currents I1 and I2 current. So, the formula for finding I1 current is nothing but I1 will be equal to del 1 by del. My del 1 value is 200, del value is 200. So, 1 amps current is my I1 current. I2 current is del 2 by del. Del 2 value is also 200, del value is also 200. So, my I2 will also be a 1 amps. Now, this is a current we have found out by using the mesh analysis we can find the currents. So, we have found out the currents as I1 as 1 amps and I2 as 1 amps. Now, we can go for finding the current in the each and every resistors in this circuit. So, what are the resistors we are having in this circuit? 5 ohms. So, find what's the current flowing in this 5 ohm. In 5 ohms, the current flowing is I1. So, I1 value I am getting as 1. So, current in 5 ohm resistor is nothing but I1 current is flowing, that is 1 amps. Next, current in the 6 ohm resistor. So, if you are seeing the 6 ohm resistor is in the loop 2. The current flowing in the 6 ohm resistor is I2. So, current in 6 ohm resistor equal to I2. I2 value is 1 amps. So, the current in the 6 ohm resistor is also a 1 amps. Next, you find current in the 4 ohm resistor. 4 ohm resistor is in the second loop. In the second loop, the current flowing is I2. So, that current will be flowing in the 4 ohm resistor. So, current in 4 ohm resistor is I2. That is also a 1 amps current you will be getting. Current in 10 ohm resistor. In 10 ohm resistor, two currents are flowing. I1 current is flowing at the top point of your 10 ohm resistor. I2 current is flowing at the bottom point of the 10 ohm resistor. So, I1 value is 1, I2 value is 1. So, 1 minus 1 we will be getting 0 as a 10 ohm resistor. So, in 10 ohm resistor alone you have to be look carefully. Remaining resistors we can write easily. 10 ohm resistor is common between the two loops. So, two currents will be flowing in your 10 ohm resistors. I1 current is flowing in the top point, it is indicated as red color. I2 current is entering at the bottom point, it is indicated as a blue color. So, both the currents are flowing in the opposite direction. So, you have to make a negative sign, I1 minus I2. So, 1 minus 1, 0 amps. These are the currents in the various branches of the resistors. Next, we can go for voltage. Voltage in the 5 ohm resistor. So, voltage means we have to use the Ohm's law formula. Voltage in the 5 ohm resistor meaning is that the current flowing in the 5 ohm resistor into the 5 ohms. So, voltage in the 5 ohm resistor will be 1 into 5 will be equal to 5 volt. Similarly, find voltage in the 6 ohm resistor. So, voltage in the 6 ohm resistor means in the 6 ohm resistor the current flowing is I2 current. That I2 current into that 6 ohm resistor. I2 value is 1. 1 into 6 you will be getting 6 volts. Next we are going to see voltage in 4 ohm resistor. So, 4 ohm resistor means the current flowing in the 4 ohm resistor is I2. I2 value is 1. So, 1 into that resistance value 4. So, 1 into 4 we will be getting 4 volts. Next we are going to see voltage in the 10 ohm resistor. So, voltage in the 10 ohm resistor is nothing but the current flowing in this resistor into that resistance value. So, the current flowing in this resistor is nothing but current in 10 ohm resistor is nothing but 0 into that resistance value 10. 0 into 10 we will be getting 0 volts. So, these are the currents we have found out, I1 and I2 currents in the loop, and these are the currents in the branch resistor. Then we have found out the voltages across the resistors in the branch. Thank you all.